excited to be here. This is both our first time at OpenSky, but really enjoyed working with the data set. It's refreshing to see so much data and so many different things you can do it. So we're thrilled. Yes, I'm Adam. This is Ismail. Before I get into it, I just want to get a vibe for where people are at and kind of what they're doing. So just by show of hands, how many people can hear me? Okay, so I've got almost 100% participation. Who has used SQL before? Okay, cool. Who knows what Postgres is or PostgreSQL? Okay, we're still good. Who's using Python as their primary language? Excellent. And is anybody developing projects on big data where you get a bit nervous before you want to run your code? Okay, perfect. Or at least you run it overnight and yeah, okay, good. So yeah, go ahead. So what are we gonna do? We're gonna cover 5 different things. We're gonna give you an overview of what is MobilityDB and what is Grafana. How do these technologies work well together? Some steps that we went through for transforming data and some analysis that can be done. We'll give you some specific SQL query examples, but really it's just to get a vibe of the idea of what's going on. So don't worry, we're not getting into too much detail. And then a conclusion of our work. We did stay up a little bit last night to put together a live demo. We'll see. So either way, it's going to be a very exciting ending. We'll see what happens.
Okay. So what is MobilityDB? So you don't need to get scared with the name. It's basically PostgreSQL. You know, Postgres MobilityDB is an extension over PostgreSQL. So it's not good. Oh, okay. Okay, so uh, when you are working with a relational database, you get many functions and like data storage and processing capabilities. So MobilityDB basically adds spatio-temporal capabilities to existing PostGIS and Postgres stack. So with MobilityDB, uh, you have temporal geometry. So adding a temporal aspect to geometry, and also you have temporal floats and ends. And I will explain what that is. But basically, MobilityDB is a relational database on PostgreSQL. Okay, so the novelty of this database is its abstract data model, which is that suppose you have 2 flights and you want to represent it in a database, you would need 9 different rows. You would need 9 different discrete points to represent the trajectory, as you can see. In MobilityDB, what it does is that it creates an array or a sequence of all the related points. So all the values with corresponding time. And it converts 9 rows to 2 rows. So the benefit of this is that you have additional functions that you can apply on these arrays and sequences and leverage the connectedness. Like the first 5 points of the first sequence are related. So if you want an average or you want to aggregate per flight, you would get this functionality. Okay, so just to give you an idea of how that looks like in practice. So you've seen this big scary table. This is a table of all the data of a single flight. So you will have approximately like 400 plus rows, 400 to thousands of rows for a single flight. So when we convert it to a MobilityDB trajectory, you will get something like this. In the lower section, you can see it will be converted into a single row. And I will explain like how all the attributes are being converted. So for attributes like iCow, which is a single value for all the rows, you just have a single value to represent the entire flight. And for attributes like velocity, latitude, longitude, which are changing over time, MobilityDB performs almost a lossless normalization process to convert it into a continuous function of sort. So you can think that you can use the graph you see in the velocity section to interpolate values between the points, and it just maintains the entire trajectory in that sense. And similarly for temporal Boolean values, you also have a temporal version of bool. And instead of using 500 or 600 values to store that information, you need a few values to store the change. So if you have a flight on ground is true for first 10 minutes, you just have one value to represent that it was true for the first 10 minutes, and in the next 1 hour, it was false, like the flight was not on ground. And with similar principles, you have temporal geometry. And in ours, uh, you can say example, we had 1 day of flights data. It was 2.5 GB. After creating MobilityDB trajectories, it was 870. So Adam will now give you overview of
Uh,
Grafana.
yeah, so a bit about Grafana. So Grafana is an open source dashboard. And on the right, you all see this great animation that's just kind of going through and showing you what Grafana looks like. It supports multiple sources, which is really nice. So whether you're using a Postgres database, a CSV file, MongoDB, whatever you're using as your source, it can take all of that in. And in your visualizations, actually, who's familiar with a dashboard? Who's like seen a Power BI dashboard, Tableau, something like that? So you're, very similar to that, but Grafana is open source. They've got a really nice community of active people, so you can develop different panels. Anything that is being developed by the community can go out and be ingested by Grafana and used right away. It's using a graphic user interface for some filtering of variables and things like that. From my side, so my background is mechanical engineering. I'm in this master's for data science. It was a pleasure to use, and it just felt very accessible to be able to quickly go when we were doing some pre-processing to go from our SQL queries to actually being able to see the trajectory, see the thing on the map very, very quickly. And playing with your markers and your colors and your sizes, and it's happening right away. It just felt satisfying. So the user experience, I'd say, was really, really nice. How do these things work well together? So MobilityDB or databases in general, if you want to visualize their trajectories, usually you're using something like QGIS. Like I said, Grafana is doing things immediately, which is huge. It's able to take multiple queries and combine them seamlessly. So like I said, different sources, if you have different SQL queries all in the same panel, in a very, again, I'm not a programmer at heart, so unions and things like this start getting a little bit confusing for me. Nested select and where statements, it gets a little bit much. Grafana kind of made it nice building blocks, made it a little bit easier to use. The big challenge I think right now is that Grafana is not able to natively visualize trajectories. So you're having to visualize discrete points, which is a bit of a killer. And I think especially for this group would be a killer, but there's a lot of people and it's open source community. New things can be developed using some JavaScript. So a bit of an overview of what we went through, 3 major steps: cleaning and transforming data, creating our queries, designing our queries and visualizations, and then finally deploying to the end user. Yeah, and let's get into it. So in the clean transform, really the big piece here is on the left. Oh, I might have clicked the wrong button. I definitely clicked the wrong button. Can I get some tech support? What you're seeing on the top left there was just dropping some rows. And then on the right, what you're seeing is that's where we're really creating our trajectories. I pressed this middle button. I don't know if that means. Here. And so when we're creating those trajectories, we're essentially taking those discrete points, and we're just like Ismail showed, we're combining them into the sequence. So in the example that you're seeing here, we see T bool sequence, T float sequence, T geom point. That's really all the magic. It's very, very simple to apply, and we're pulling all those things together and creating these 3 different sequences. This happens once. This happens on data ingestion. Once we're actually querying and playing with the data, we're no longer doing the transformation. So the second step, creating and designing our queries, the big takeaway here is that when you're dealing with your big data and you're dealing with a dashboard, you want to be pushing your query so that all the work is happening at the database, and you're limiting the amount of data that's coming back. So Grafana can do filtering and things like that on the front end, but that means that all that data is coming back, and that really slows the whole thing down. So that was really the focus of designing our queries. And then finally, deploying and responding to the end user requests. The nice thing about Grafana that it provided was user variables. So you have your nice block of SQL query. A user variable can be injected into that directly and graphically. So now we're able to, and this is, you kind of see on the bottom left there, an example of a final product. So now a user that has no SQL experience can start playing with data and seeing things. So if you're talking to managers, directors, people that don't really know how to play with the data, they're at least able to point and start to see things in ways they weren't before. And it's really an empowering, we're really helping to empower everyone with the data, which is an important piece here. So we'll go over a couple of SQL query examples. We build things up a little bit, block by block, so starting simple, and just highlight a couple of the important aspects of how these work.
Okay, so in this query, we just want to highlight some of the features of Grafana. Like it's a very simple query. One of the limitations of Grafana is that it is not able to handle like big data or lots of data right now. So to make it responsive, we return the sample of data. Uh, just to get an idea of the trajectories, it's good enough. And other thing is that's used here is Grafana variables. So this allows us to use GUI buttons to interact with the query as opposed to changing values all the time. And this one is like one of the interactive graphs of Grafana. So with this one, we can plot two different values that have different time scales, like on different axes, and we can zoom in, zoom out, shift in time with the GUI. And we also have a tooltip to really give us all the information, like what the uh, exact points are at that specific place. And with this Grafana, you don't need to bring the data in from one database or one source. Like multiple sources can be coming in from, like multiple streams can be coming in. So like one data is coming from ADVS and one is coming from Eurocontrol. So that's also possible.
So this next query, creating flight trajectories, this is one of those that's happening on the back end, just happening the one time. So the problem that I think is I think solved. I think Traffic has a really nice function that just does this directly. But that problem is, how do I get one flight? Because I have an airframe that has multiple call signs, but I can also have a call sign that has different airframes because that call sign is representing a flight. So how do we just extract one flight? And this is kind of the show of how we do this with MobilityDB. So that first little block, what we're doing is we're retrieving the start and end time of each flight, and then we're using that as a tool to slice all of our other variables. And this is kind of where, when we're starting to talk about big data and speed, this is when you only have to do your calculation once, and then you can apply that to everything else, instead of having to apply it every single time on your vert rate, your altitude, your latitude, your longitude. At this point, you're doing your calculation once, and you're able to use that as a tool to slice your other data. And so this is where we're creating those trajectories. So this query is kind of bringing things home, bringing things together. So for all flights taking off at any given time, how did the vertical ascent rate change over the course of takeoff? Let's just say that you or your manager or part of your research is about understanding this aspect. So what we do here is, first, we use a user-defined time range to figure out, are we looking at July 22nd, 2021 to July 23rd, 2021? Okay, that's my time range. You now use that as a tool to start slicing different things. So we return all of the parts of the flight that fall within that time range. And then secondly, because we're looking at takeoff, we decided takeoff is when we have an ascent rate that's positive. We decided between 1 and 20. So now we're going to take all of those flights that fall within our time range, and we chop them up into new sequences that are all for each flight. We now have a bunch of sequences where the airplane is ascending. And then we want to take just the first one of those ascents, which is takeoff. So we kind of go through, slice some more, pick the first one, and now we've got our takeoff. And then again, because we can't do trajectory visualizations, we're taking that trajectory, unnesting it back into our data points, and now we can visualize in Grafana. And another, so this is the visualization that kind of comes of that. Then now in Grafana, you play around with your marker sizes, your color schemes, things like that. You can see on the top right, that's just one of the flights that we've looked at. An interesting thing that you can see right away is at the tail end of that takeoff, there's this increased ascent rate. So if you're looking at something like CO2 emissions, if you're looking at efficiency, now forgive me, I don't know how airplanes are supposed to take off. I didn't look at the reference docs for that. But this for me kind of indicates maybe there's something of concern happening at that particular point in that flight, or maybe it's at that particular point in the air. Maybe there's something going on, and it helps us visually kind of start to get into it. I think maybe let's skip this one and go into the demo. Let's try. Yeah. If you start setting the demo up, while he's doing that, this last one was showing a heat map. So again, one of the ways that we can get around not having trajectories is either using discrete points and enough of them that you see the line, or you can use a heat map to impose things over each other. So again, fingers crossed, everything works. I know demos are risky. So we got through the content already. So if it fails now, don't fret. We're good, but we're going to try to walk through, because I think seeing it live and being able to kind of see how it works is really the nice part of it. Were we not? Oh, because they're doing it for, okay, for our friends online. So I think one thing I won't show is that we have the nice visualization panels. Within each one, when you create a new one, you can, if you're developing in your IDE, you can still do that. You can take your SQL query, drop it right into the panel, and work that way. Beautiful. Great. Okay, I'm going to speak before it goes away. So on the top left it's a query that's basically returning for an airframe, what were all the call signs that existed for that particular airframe. Very basic, no visualizations, just returning basically a table. What we hopefully will see is here we have one airframe over a 24-hour period. And again, this was pretty quick, but we're seeing by color, we're seeing the, I believe it was altitude, or I think ascent rate. So we're seeing on a 24-hour period, you see one airframe. Now, we've also got altitude versus time. Can you, yeah, this one's fine. We got altitude versus time, ground speed, all these kind of different factors. Very quickly for us, as we're exploring data, this was our first time looking at the data set. My guess, just looking at this, is I had maybe 1, 2, 3 and the beginning of a fourth flight. And without even understanding what the OpenSky data set looks like, we were able to really start understanding it. You're able to very quickly kind of zoom in, and all your panels you're able to set them up interactively. So in this case, we now just are looking at 2 of these, and right away can you zoom in just on maybe one flight? Our panel with the map also updates and starts to show us where were we when this happened. And so this is just a really, and can you scroll up a little bit? So it becomes, I'm not seeing that it's updating. Maybe there's a bug on that one. But you can see how, if it all worked, updating one you can see the dynamics of how things shift. So if you're trying to manage and understand different potentially connected variables, and you set your code up, you can start to manage in different chunks and kind of look around your different data in different chunks. And why don't we take a look at the last ones? So on the bottom right here, you can set up Grafana variables. So I should say, sorry, at the, can you show me the very top left of the panel where the variables are? So you can set up user-defined variables. The variables can be based off of a query that you do. So you can query a table, and the results of that query become variables. Here we set up just manually, we set up some manual variables. And then on the top right of the panel, there's what are called Grafana variables. So they're already predefined variables. And these are the things that are getting injected into your SQL queries. So depending on what you want to pick here, again, you can, if we go to the very bottom panel, if you're looking at specific airports, or you want to look at air traffic control blocks, you can set up your geometries so that you're injecting the geographic location of something. So if you're very, very curious about just Amsterdam, then you can quickly, from a drop-down perspective, look at all of my flights between 9 a.m. to 12 p.m. going, landing in Amsterdam. And if you know that that's what your colleagues or, again, dashboarding usually for kind of management level reviews or information, if you know what information they're going to want, you can set it up so that without code, people can start moving through. Again, we found that it was very nice just to visualize even for reporting and things like that. Quite nice. But that's in a, and then here we see heat mapped. You can kind of see hour by hour. I think this was 10 a.m. over Amsterdam, 10:30 in a 1 hour window. So these are any flights that are crossing, or sorry, this was Brussels, my bad. Any flights that we had to come back to, we're representing ULB, so we figured come back to Brussels. Any flights that crossed over that airspace are shown here. Can we go back to, no, I think this guy.
No, this is not connected.
This is this guy. Oh,
this is not connected.
okay. Yeah. So we'll wrap up just as talking to you guys. I now understand Python's where we're at. Databases, is anyone using a database with data in it when they're doing their work? By show of hands, anyone actually using a database? 1, 2, 3, 4, 5. Okay, totally understandable. So I want to bring attention to this. So MobilityDB is a Postgres extension. Recently, what's been done is they've taken all of the functions and data types and everything that they've done, extracted it, and created PieMeos, which is a mobility engine open source. It's a C++ engine, and it's basically now able to be used for other things. So this past summer, while Ismail and I were working on some of this stuff, our colleagues were working on PieMeos, which is taking those Meos functions and functionality and wrapping it for use in Python. And also this summer, Moving Pandas is starting to apply PieMeos as its underlying a framework for doing the dependencies. So if someone that's working with traffic is interested, we can certainly talk about it, but I think there's a lot of opportunity to start wrapping this stuff up in the back end. So if you know your traffic calls and you're comfortable with those and your code works, it's quite easy to have Meos working in the back end and just kind of doing the math on you. In that last presentation, especially, I heard so much about intersecting geometries, intersecting trajectories. This is the space where what we found is working in, let's say, traditional data frames is challenging because of the size of the data, or even ADBS versus Eurocontrol. Really what this is doing is taking all those discrete points and creating nice continuous functions that are much easier to process when you're dealing with these tens or hundreds of gigabytes. That's where these improvements really start mattering. So I just want to highlight that this exists. As someone else pointed out, if you're on your laptop, just go to Google, type in the word PieMeos, and just leave that tab open and take a look later. And actually, I should also say, because we went to ULB, our professors are the ones that have been developing MobilityDB and everything. So am I sorry? I'm sure I came off as a little bit biased because I think it's super cool what's able to be done with it. And now that I've actually played with it is quite interesting. So in conclusion, MobilityDB is a Postgres extension. It's open source. It's got spatial temporal data types. From the work that we did, we saw 3-to-1 compression, 3-to-1 lossless compression of our data when working with it. It's lacking, it's very generic, so it doesn't have any flight-specific functionality, which we would love to see. And I think being able to develop those will really be a nice extension. There is work that's happening between MobilityDB and the FCC right now. So they've kind of started down that path, as well as some other, I think, Toyota self-driving cars. Like there's different players that are starting to definitely look at it. Grafana on the other side, a dashboarding tool, also open source, lots of different data sources, able to natively do map visualizations, but starting to fall down a little bit when we're talking about trajectories. So being able to develop that, and I think probably some of you have seen Kepler, anyone work with Kepler GL for their animations? Yeah, so that was another thing that we really wanted to be able to see that in Grafana, and it's not quite there. I'm anticipating next couple of years, as people pick up on it, it will be, to be able to watch it play instead of having to click through would be a really nice extension to see. So yeah, I think thank you very much for having us. Thank you for your time. It was really grateful to have been here and talk to you. Thank you.